Elon Musk recently became the world's first trillionaire. But here's the part engineering students must not miss. A huge part of that value came from SpaceX, roughly $866 billion from one engineering company. So the real question is not how did Elon Musk become so rich? The real question is what kind of engineering mindset creates a company like SpaceX? Because SpaceX did not become rich by just saying one day, let's go to space. It became valuable because Elon Musk looked at one of the hardest industries and asked, why is space travel so expensive? Why are rockets only used once? And why can't the most expensive parts come back and fly again? It became valuable because Elon Musk looked at one of the hardest industries in the world and asked these questions. And that is the part worth studying. Not the wealth, not the hype, not the controversy, but the engineering mindset. And to build that mindset, you need these three timeless qualities. And the best part, these are absolutely learnable by everyone. And any engineering student can build them. So what are these three qualities? Let's look at them. Elon Musk often explains his thinking through a simple idea. Don't reason by copying what other people are saying. Break down the problem into its most basic truths and then build your answer from there. And that idea is the foundation of SpaceX story.
I think it's also important to reason from first principles rather than by analogy. First principles is kind of a physics way of looking at the world. And what that really means is you kind of boil things down to the most fundamental truths and say, okay, what are we sure is true or as sure as possible is true? And then reason up from there. That takes a lot more mental energy.
Most people looked at space travel and accepted the system as it is. Space is expensive, rockets are difficult, launch costs are high, and that's just how it works. But real engineers are not supposed to follow systems blindly. A real engineer looks at the same system and asks, why does it work this way? What's the actual problem? Can it be made better? And that is where the first quality begins. For decades, space launch felt like something which only governments or passionate space agencies could do. NASA could do it, big national space programs like ISRO could do it, but a private company doing it at a scale sounded almost impossible. Most people accepted space as expensive, but SpaceX asked a very basic question. Why does space travel have to be this expensive? That question changed everything. Because real engineering does not begin with answers. It begins with better questions. Most people look at a system and say, this is how it works. But an engineer asks, why does it work this way? Can it be changed? Can it be made better? That is curiosity and not casual curiosity. Not watching a rocket video and being inspired for 10 minutes. Engineering curiosity means questioning what others seem to have accepted as normal. For SpaceX, the curiosity was with this question: why should space travel be expensive? Curiosity alone is not enough, because questions alone do not build rockets. Because after asking the right question, you also need to find the right answer. And that is where the second quality begins. SpaceX did not just say, let's build rockets. That would be too broad. They had a sharper insight, which was a big part of the rocket cost comes from throwing away expensive hardware after every launch. Imagine buying an aircraft, flying it once and then throwing it away after the trip. That would sound crazy, but for a long time, rockets almost work exactly like that. Launch once, lose expensive parts, build again, launch again, lose expensive parts again. So SpaceX focused on the real bottleneck. What if most expensive parts of the rocket could come back? What if they could land safely? What if they could fly again? That decision changed the economics of space travel. Reusable rockets were not just cool to watch. They attacked the cost structure of space itself. And that is judgment. Judgment means knowing which problems are worth solving. A beginner sees a problem and gets excited. A real engineer asks, where is the real cost? Where is the real friction? Which problem, if solved, changes the entire system? And that is the difference between a big idea and a useful engineering decision. But even if your question is right and your judgment is right, solving the problem doesn't simply become easy, because the real world does not just reward ideas. It rewards working systems, and that is where the third quality begins. Reusable rockets sound obvious after they work, but before they work, they looked almost impossible and sometimes even stupid. Think about what has to happen. The rocket has to launch, the payload has to go to space, the booster has to separate, and then that booster has to return through the atmosphere at the right speed, at the right angle, with the right control, and then it has to land safely. Sometimes even on a floating platform in the ocean. That's not a small challenge, and the early attempts were far from being successful. They were failed landings, explosions, missed targets, public failures. But SpaceX did not treat those failures as the end. They treated them as data. What failed? Why did it fail? Which part of the system needs to change? And what should the next version do better? And that is adaptability, not just a never give up kind of a thing. Because that sounds motivational, but it is incomplete. Engineering adaptability is a lot more specific. Study the failure, read the data, change the design, and test again, build a better version. That's how failed landings became successful landings. And that's why SpaceX today is a powerful engineering case study. It shows that engineering is not about getting the right answer in the first try. It is about improving the system try after try. Now, you may not build rockets, you may not even build a space company. But if you are an engineering student, you will build something. Your first website, your first Python project, your first AI tool, your first app, your first hackathon prototype, and most probably your first version will fail. The design may look bad, the code may break, the user may not understand it, and the demo may crash. Your idea may feel too small. But that does not mean you're not made for engineering, because this is exactly where engineering actually begins. Because a real engineer is not somebody who has all the perfect answers. In fact, a real engineer is someone who can improve imperfect systems. So when your project fails, don't just say, I am bad at this. Ask, why did it fail? Where is the real bottleneck? What should I change in the next version? And that is how you start building the engineer's mindset. Curiosity helps you ask better questions. Judgment helps you find the real bottlenecks. Adaptability helps you improve after failure. These are the qualities which made SpaceX valuable, and these are the qualities every engineering student can adopt in their own life. Stack is the real reason behind Elon Musk becoming a trillion. Money is just a headline and SpaceX is a case study. But the engineer's mindset, that's the part worth copying. Don't copy the controversy, don't copy the hype, don't even copy the personality. Just copy this engineering mindset pattern. Ask the question everybody skips, hunt for the real bottleneck, turn failures into version 2, because that is not just the SpaceX quality, that's the mindset of a real engineer. And if you're serious about engineering, that's a mindset you should start building right now. And if you're somebody joining an engineering college for computer science engineering, there are 8 things you must know before your first day in college. The link is there in the description, just check it out.